Hello everybody, welcome to the new section. So in these sections we are going to cover NumPy array part 2. So we will keep working building new arrays using the NumPy library. So let's dive in. So before diving to the coding, I just want to make a small reminder about the matrices, and basically these matrices is being used as a 2D arrays in a NumPy. So right now, as one of the matrices is identity matrices, what does it mean? That we have a perfect square, so the amount of the rows is the same of the amount of the columns. So right now I have a 2 by 2 matrix here, and in order to make it identity, so all values are 0. The only thing diagonal values are going to be 1. So for this case we have a 1 here and 1 here as well. So I have a 3 by 3. So right now that is my 2D array. I have a matrix which is 3 by 3. That means I have a 3 columns and 3 rows, and all my ones are located diagonal, and rest of them is going to be 0. And if we bring like in different samples, so right now I have a 2 by 2, so that is a 2 by 2, that is a 3 by 3, 4 by 4, and 5 by 5, and as you see I have all ones located as a diagonal. So let's see how we can make the same 2D array using NumPy. So first of all, we need to import our NumPy library. So what I can do is I will say import NumPy as np, and I will run it. It will take a couple seconds to import it. So right now it's running, it's done. And in order just to make sure that NumPy was installed, what I can say that I will type np and dot, and I can see all built functions. So right now those functions are built in my NumPy. So my NumPy is ready to use. So one of the functions that we need to use for creating identity matrices is an np.eye. And after that, I will provide one argument only. So do you remember that the identity matrix is a perfect square? So the amount of the rows is the same as the amount of the columns. So if I provide number 4, that means that is going to create a 2D array with a 4 by 4 dimension. So let me run and let's see how it looks like. So right now I have my 4 rows, I have a 4 columns, and all ones are located diagonally, and the rest of the values are the 0. Perfect. So let me just do something a little bit bigger matrix. So what I can say that np.eye, and I will provide just a little bit big matrix. So I will say 10. That is going to create me 10 by 10 2D array. So if I run it, I can see my 10 by 10 array, and all ones are located diagonally. So another function in the NumPy library to generate arrays, so there is, let me just show you, I will say NumPy and random. So right now, as you see, let me just pull it a little bit up. So np, it's my library, and after that we have a random, which is function, and after that if I put a dot, I see different methods. So that method belongs to the function, and the function is the part of my NumPy library. So right now I will show you the rand, which is that is going to populate different random numbers between 0 and 1. So if I put a 1 digit only, like in one argument only, that is going to generate 1D, one dimension array with 5 different values, 5 different random values between 0 and 1. So if I run it, so perfect, I can see 5 different values, and all of them are between 0 and 1, and that is my 1D array. But if I want to make a 2D array, what I can do is I will use the same function and the same method, and here I need to provide my the dimension of my array. So here I will say it's a 5 by 5. If I run it, it is going to generate me 5 by 5 2D array with all values, all random values between 0 and 1. And by the way, let me just remind one more time, by seeing that array, how we can understand that array is 1D or 2D, you can just basically see the amount of the brackets you have in the beginning or in the end. So if you see 2D, two brackets, that means I have my 2D array. You see, on the top we had example that if I have only one bracket, that is a one dimension array, and that is a 2-dimension array. So another method in the random functions, what we can say that, let me just pull it a little bit up and I will show you. So right now that is my NumPy, that is my library, and after that I have my function, and after that I have a couple methods. So you can just go ahead and analyze them and see what kind of different methods we have. So one of them is a rand int. So that is going to generate me one random number, but I need to identify what is my start point and what is my finish point. So right now in the brackets, I will put two different values. So for example, I will say 1 and 100, but do not forget that 1 is included and 100 is not included. That means this one has a chance to be picked. So right now, if you run it, it is going to generate me a random number between 1, which is inclusive, and 100, which is not included. So if I run it one more time, it is going to generate a different number for me. And after that, I can just provide another value, another argument saying that how many different numbers I want to generate. So right now, if I put a 10, by saying 10, what I mean that it is going to generate me 10 different numbers, which is between 1 and 100. And if I run it, it is going to be generate me as array. You see, right now I have 1D array with 10 different values, 10 random values between 1 and 100. So another function in a NumPy, let me just show you, I will put a little bit up. So right now, I'm going to generate one array, and let's see how we can change the shape of my arrays. So right now I can say that from the NumPy, I will use the arrange, and I will provide a number. Let me pull 25. Let's see what it's doing right now. It is going to generate me one array starting from the 0 all the way to the 25, but 25 is not included. So and what I can do is I'm going to save this array to a different variable. Let me just call it array, and I will save it. So if I run it, it is going to, so that array was saved to that variable. So later on, if I need that my variable, what I can do is simply I just recall it, and I have that. So right now it looks like I have a one-dimension array with 25 different values. And if I use this variable, what I can say that array and dot. So right now I have a different function as well. So I can say that I want to reshape it. So right now I'm taking one-dimension array and reshape as a two-dimension array. So what I can say that I will put a 5 by 5. So basically what it is doing, that it is taking my array, and what is my array? That is here. It was generated with the 25 different values. They are here, and that is reshaping one dimension to the two dimension. So, but we need to be a little bit careful about these values. If I provide different size, so let me pull it 5 by 6. That means I have 5 rows and 6 columns. That means I need to have 30 different values, but I have a 25 only, so that is not going to be fit in. So right now it is going to give me error because it says that I have a 25 values here, but my matrix is a 5 by 6. So I need to be exactly the same one that we have as the amount of the different values here. Let me show you another function that is built in a NumPy. So right now what I'm going to do is I will generate another 1D array. So I will use the np random, and from the random functions I will use the method rand int, and I will tell that start from the 0 all the way to the 50. So that is going to be my range, and I will tell that generate 10 different numbers. Let me run it. So perfect. Right now I have a one-dimension array. It has a 10 different values between 0 and 50, and let me just save it to, I will just give it different values. So right now I will say, let me call it random array. I will call it rand arr. So if I run it next time, if I want to see what is my 1D array looks like, what I can say that the rand arr. So that is going to post me my array. Perfect. So right now what I'm trying to do is, imagine that you have a long array and you're trying to figure out what is your maximum value is. What you can say that random arr, and after that I need to recall my method. And so from here I can say maximum. So if I run this my method, it is going to pull out what is my maximum value is. So in the same way I can say that from that array, bring me the minimum value. So that is going to bring my minimum value. So I have a 0, that the 0 is here, and I have a 49. So the 49 is the biggest, is the maximum value. And also I can find out in where it is located. So for example, I will say random rand arr, so that is my variable, and from here I will say argmax. So what is the argmax stands for? It is going to show me where my maximum value is located. So right now if I run it, it says 5 because it is my maximum value is located on the 5, so that is my 0, 1, 2, 3, 4, 5. So the 49 is located in the index 5. So the same way, if I say the rand arr, that arg mean, so that means it is going to show me where my minimum value is located. So if I run it, it will say that my 0 is located on the index 0 as well.